Okay, so let's get started. The line is muted to all except those who will be presenting tonight. Up first, we're going to hear from Ross Heiner, our Dam Safety Program Manager, who's going to give us an overview of the Dam Safety Program and ongoing dam safety projects happening in the Valley. After Ross presents, we're going to hear from Eric Peterson, our Operations Project Manager for the Willamette Valley. Eric is going to go over current water conditions, forecasts, and how we plan to manage water throughout the upcoming months. All right, I'm going to pass it over to Ross. Ross, if you're speaking, I think you're muted.
I was muted, thank you.
Yeah, of course.
Thank you for the introduction, Lauren, and thank you to Eric and your team for allowing an opportunity to present and take some of the time from your presentation to share some updates from the Dam Safety Program. Thank you to those in the audience and for calling in and joining us today, and appreciate your interest and your time to learn more about the current conditions at the dams and so let's get started. So my agenda for this first presentation before I hand it over to Eric is give a brief overview of the Willamette Valley Basin and the projects we have that we operate in the basin, how we balance flood risk with the conservation uses, and then get into the Dam Safety Program, give an overview of the program and an update on some activities that we have going on, including risk assessments and some risk reduction activities. So I guess before I begin, I'll introduce myself. My name is Ross Heiner. I'm the Dam Safety Program Manager for the Portland District. I've been in this role for about 3.5 years, and been with the Corps for about 13 years as a structural engineer. And this is a very, very exciting position and job and role with the Corps, just because of the scale and size and the variety of projects that I get to be involved with. And it's a great team to work with as well, both the engineering and the operations side of the house. So this slide shows an overview of the 13 dams that make up the Willamette Valley Project, and as it indicates, these are multi-purpose dams, and so they provide different purposes and have different goals depending on the time of year, and I'll try to explain that a little bit. So Fern Ridge Dam out in west of Eugene was the first dam of the system that was constructed in 1941, and the 13th project completed was Blue River Dam in 1969, and so that was 51 years ago. So last year we celebrated the 50th anniversary of the Willamette Valley Project as we know it today. There's a lot of variety of different structures included in the system of the Willamette Valley Project. We have the very large concrete dams that many are familiar with at Green Peter and Detroit. We also have the very large embankment rockfill dams like Hills Creek, Cougar, and Blue River. And some of these are very, very impressive structures, and it's our job in the Dam Safety Program and operations to maintain their safety, and so we're being good stewards of the designers and the authorized purposes that they were constructed to perform. So that each project is unique, and that's kind of what makes my job very interesting and exciting, is learning about all these different projects, the different site conditions, the different considerations in design, and then also assessing the performance and history over the last 50 plus years of their presence. So this is a rule curve that some of you are probably familiar with, and kind of a generalized roll curve using Fall Creek Dam as an example of how we operate throughout the year and balance the different needs for both flood risk management and conservation storage. So this roll curve is broken out for every day of the year, and so this is a water control diagram that dictates the goals, regulation goals for each day of the year throughout the water year. And so starting in November is the start of our major flood season, and so that's when we're at the minimum conservation levels and have the most amount of flood storage available for the wet winters and winter time rain events that we experience here in Oregon. And so the roll curve is at its minimum through the month of January, and then at the end of January, beginning of February, we start to refill along this roll curve, which is used as a guide and a regulation guide to set the allocation of the reservoir to make this balance between the available flood storage and the available conservation storage. So our major, we're approaching our conservation season currently, and this is our goal for each project, is to reach this elevation to provide this conservation storage to meet these other benefits, water supply, water quality, fish and wildlife, and hydropower throughout the summer and the dry summers and fall time frames. And so this is Eric described it as a delicate dance many times, and it is this dance between balancing this flood risk and flood storage with the conservation needs that the region really depends on. So in dam safety, I see myself and our program as an advocate for life safety and flood risk management associated with our projects. And so these are the components of our dam safety program that our staff and our team, not only in engineering, but to include Eric's team in the Valley, to provide a robust system process for inspections, training, monitoring of these projects over time. So highlight a few of these items. Periodic inspections are performed on a 5-year basis, and these are deep dives and very detailed hands-on inspections with pretty much every component that makes up the dam. So there's a picture here of the regulating outlet at Lookout Point Dam, and you have some hydraulic engineers that are looking at the regulating outlet gates. And so this is a component that's normally underwater, and so on these types of inspections, we set bulkheads and dewater these components and get a hands-on, up-close view of these components to look for any signs of distress, any signs of wear and tear, anything that we might need to that might preclude their safe use into the future. So this
conference is being recorded. Only the main conference is recorded.
These periodic inspections are a fundamental part of our program, and we've been doing them for the past 50 years or so. Annual inspections are an annual review of those outcomes of the periodic inspections and an on-site inspection of the structures. But Eric's staff and the teams of the projects are out at the project's minimum every on a weekly or monthly basis to perform monitoring of instrumentation that we have at each of the projects. And so these instruments have been installed at the dams dating back many times to original construction. And so these instruments measure the water levels and pressures in and around the dams and their foundations, and really give us a long history and a large data set of information to monitor the performance of the dams over time. And so this information is really critical, and that we are into our risk assessments, which I'll talk more about later. Probably the biggest part of our dam safety program is the operation and maintenance activities that we do at all of the dams. And so the day-to-day preventative maintenance tasks, the lubrication of components, the testing of components, inspection of components is important to give us reliability that these the dam's components will perform when they're needed to pass water through the dam and do other functions. So kudos to Eric and his team for for a robust operation and maintenance program that we'll speak a little bit about later on. But the dam safety program kind of helps identify some of those activities, and I'll give an example of one project or a series of projects related to spillway gates where we really made improvements on both the reliability and the risk picture associated with our dams. So risk is a term that I'll use a lot and has used a lot for different aspects, and everyone kind of has a different definition of risk, and probably the simplest definition of risk that I can provide or that I've heard is that risk is defined as something bad may happen. So something bad may happen has two key components. There's something bad that can happen, so there's a consequence. There's a consequence to that, and then there's an uncertainty or a probability of may occur either now or in the future. And so in dam safety, since we do very quantitative risk assessments and make a lot of decisions based on risk, it's important to have a consistent definition and a consistent usage of risk. So we define risk in three distinct components. And those are the hazard, the performance, and the consequences. And so in our risk assessments, we dive into great detail into all three of these different components. So the hazards can be any type of loading condition or scenario that may impact the performance of the dam. So it could be normal operation, normal pool fluctuations up and down throughout the year. It could also be, we also look at extreme flood events, large hydrologic events. So we come up with hydrologic loading that's probabilistic in nature. And then also earthquake loading. Pacific Northwest, we're exposed to the Cascadia subduction zone, and so we have a lot of, we're relying on a lot of research from the USGS, other universities, institutions, and some internal experts to study the Cascadia subduction zone in detail to define what are the most likely scenarios, what are the most likely ground motions that we may experience at the project, and then extend that to some of the most extreme scenarios that we might experience into the future. And so the second component is the performance. And given that loading or those conditions that might impact the dam in the future, how is the dam likely to respond? How is it going to perform? How likely is it to perform satisfactorily? And what are the potential ways there could be a problem? What can go wrong? It could be a component of the dam. It could be the main embankment. It could be, we look at all the different components and try to determine different ways that there could be an uncontrolled release of water from the project that could result in consequences. And so consequences are a very important part of the risk assessment and really inform what type of reliability we need out of the dams. And so in the Willamette Valley, because of the setting and the size and scale of our projects and our dams and the populations that live downstream, the major population centers downstream, there's potential for high consequences associated with a dam failure of any one of our projects. So that forces forces us to look at very extreme events and test the structures in our analysis to some very extreme scenarios. So those three components all go into a risk assessment. We have various types of risk assessments. We have a routine risk assessment that we do on a 10-year basis, and then we have more advanced risk assessments that are prioritized at a national level that are a deep dive into the dams things. And so those advanced risk assessments we have ongoing at many projects that I'll show on the next slide, but can include very detailed analysis into all three of these things. We've done site-specific probabilistic seismic hazard analysis to gather all of the expert information about the Cascadia subduction zone and other earthquake sources to have a probabilistic look at the different at the seismic setting in the region and at those specific dam sites. And we've done, and we're continuing to do advanced analysis, engineering analysis on how the dams will respond to those different earthquake loadings. And some of the activities that help inform that performance are taking samples and drilling into the embankments themselves. You may have seen over the last several years, drill rigs at some of our projects taking borings of the embankments to sample the materials to test the actual material strengths and material properties, and that gets fed into computer models and simulations of the performance to better estimate how the dams are likely to respond in those scenarios. So here's a lot going on in this slide, but we've got our definition of risk over there on the left, and then I'll point your direction to this bottom left where we have the risk classifications. And so in the core we have 700 dams across the nation, and so we have a standard classification for all of those dams, and we have 5 different categories, and this is a way that the agency prioritizes our advanced risk assessments and our dam safety modification studies. So there's 5 categories from very high to very low, and those are shown here on the chart on the right for the different projects. The risk assessments, and so we update those risk classifications based on various risk assessments. I talked about the routine risk assessment we do on a 10-year basis, and then at a national level, the advanced risk assessments called issue evaluation studies are prioritized, and we have several going on in the Willamette Valley. A couple of them are concluding and moving either back into the routine program or onto a dam safety modification study. The modification study phase is a chance to look at long-term solutions to reduce risk associated with the projects. And the modification studies will look at structural solutions, strengthening of components, as well as operational changes and other risk reduction measures and combinations of those to come up with long-term solutions to get risks to a tolerable level. So this is a summary of the different activities and the current or most recent risk assessment study and the resulting risk classification here. I'll highlight a couple of these. I'll talk more about Lookout Point here in the next couple of slides, but we're beginning a modification study on Lookout Point, and recently the dam was reclassified from a high-risk project to a moderate-risk project, but there's some, and I'll talk more about that later in the presentation. Green Peter is an example. This is a pending change. It was classified as a high-risk project. Now it will be classified as a low-risk project based on this advanced risk assessment that we performed, that we're wrapping up and completing in the next couple of months. So I mentioned spillway gates and some of the operation and maintenance improvements and reliability improvements we've made at our projects. And starting in about 2010, some of our inspections, climbing inspections, issues with the spillway gates at Foster Dam and some other dams. And so this is a picture looking at the strut arm or the in frame of a spillway gate. And you can see the slight bend and deformation of the structural member there. And so that was an early warning sign that these components might be overstressed in their operation, and there's a potential problem that we needed to address. And so through inspections and analysis of these gates, it was determined that they needed to be upgraded. The issue was related to wear and tear and lack of lubrication of these and high friction in these hinge points that we call trunnion pins. And this high friction values resulted in overstressing of these end frames. And you can see here's a type of repair that was done, or a schematic of that. You can see the red stiffener plates that were added to the existing structure that help give additional structural strength to the gates. And then at Big Cliff Dam here, this is a picture of the 3D spillway gates there, and the fix at that project was to replace the entire end frame with new materials that are higher strength and less friction in these hinge points. And so over the last decade, we've made tremendous progress in rehabilitating not only the structural condition and structural reliability of the gates, but also the electrical and mechanical reliability. So a strong, strengthened gate doesn't do you much good if you don't have the reliability of the equipment to raise and lower that gate. So we've completed, a vast majority of spillway gates. We've performed construction and rehabilitated those gates. There's a little bit of work to do at Detroit, Cougar, and Hills Creek, but at least there's partial completion. We have an ongoing construction project at Detroit right now. So we've got, we're working over the next couple of years to really finish all of these projects out, which is a real accomplishment for the district and for the projects and really the communities that rely on the infrastructure. So interim risk reduction measures are a way that while we're going through the risk assessment process, we identify potential problems or issues associated with the dams. We can implement short-term measures or interim measures that reduce risk while we study the problems further or look for those long-term solutions in a modification study. And so I've listed some examples of those interim measures that we are taking. Increased surveillance and monitoring of the projects at certain times and certain pool elevations and certain conditions. Planning and exercising our emergency plans is a key component in communicating risk to those emergency managers that we have relationships with, and also events like this to raise awareness with our stakeholders and the general public. Operational changes and restrictions are also included and considered as interim measures. One example that we've implemented in the past related to spillway gates is these gate tracking restrictions, and these have been lifted as we've constructed or finished the rehabilitation of the spillway gates. And so what these measures did was reduce the probability of overloading those spillway gates and resulted in a loss of that available flood storage, and caused us to, if needed, if we had flood events that would potentially put the spillway gates in danger, we would open them prematurely or open them to release water sooner than we otherwise normally would. And so since we've completed those spillway gate projects, these restrictions have been lifted at several projects, or basically all of our projects now. So specifically talking about at Hills Creek, these are interim measures that we will be implementing. We are implementing this water year, and they are in response to results of the issue evaluation study and recommendations from showing the simplified cross-section of the dam and the earthen embankment that retains the reservoir. And you can see that the height of the dam, the scale is pretty close to true, but it's approximate, is about 341 feet. So the foundation of the dam up to the dam crest, or the top of the dam, which is set at elevation 1548. That's feet above sea level. Normally, our maximum conservation pool, our target refill elevation is at elevation 1541. So only 7 feet between the top of the dam and the top of the reservoir at its maximum elevation. And so there's a concern with really extreme seismic events, those well beyond the average expected Cascadia subduction zone, but within the realm of probability that the ground shaking could result in some shaking of the embankment and a lowering, settlement and lowering of the dam crest. And if there was additional, settlement in excess of the available freeboard, which is the vertical distance between the top of the dam and the top of the reservoir, then the embankment could begin overtopping, and that flow of overtopping going over the dam would result in a breach of the entire structure. And so that obviously would result in a large amount of water being released, a large amount of flood inundation, and ultimately a large loss of life.
When I was trying to print on the printer, it was only printing in black and white.
Sounds like someone has a hot mic, if you wouldn't mind muting.
So that scenario would not be ideal, and would be very catastrophic. And so that's something we are looking to study further, the performance of the dam in those extreme earthquakes, but also we're taking interim measures to reduce the probability of that occurring. And so our interim measure
that... a different color. I had it run a test page.
Hey, Ross, I'm going to mute all lines again, and then you can unmute yourself.
Specifically for my computer. And I feel like Maggie had this problem with her.
Okay, I'm back. Thank you for that, Lauren. So the interim measure that we're taking at Hills Creek is to reduce this target pool elevation by 10 feet. So that doubles our amount of freeboard, more than doubles the amount of our freeboard, and reduces the seismic risk very close to zero. And so that's our goal, is to take as much probability away from this type of scenario as possible, so that type of failure mode will not occur. And so this only affects our refill for very abundant water years, and we published an environmental assessment that summarizes some of the potential impacts. And Eric will talk a little bit about the impacts, or lack of impacts, that this has had this year. At Lookout Point Dam, downstream of Hills Creek, we have more of a concern with the spillway gates and their seismic performance. We have upgraded and strengthened certain components of the gates for trunnion friction. However, the extreme earthquakes that we are assessing the dams for are seen to potentially overstress the gates and potentially the piers. And so what our interim measure is at Lookout Point is similar, is to reduce the maximum conservation pool by 5 feet, and that reduces the amount of potential water on the gate during an earthquake to reduce those forces, and to give us a higher reliability and seismic performance of the spillway gates. So that concludes my presentation. I will now hand it off to Eric Peterson, Operations Project Manager, for an overview of this year's conservation season outlook. And also I'll be looking at the chat box to see if there's any questions that you have submitted that I might be able to address. So Eric, the presentation mode is coming your way now. Thank you all for your time and attention today, and take it away, Eric.
All right. So, Lauren, let me do a quick sound check with you. Can you hear me okay?
Can hear you great.
And my desktop is up?
Yep.
Great. Well, Ross, thank you for your comments and overview of the dam safety program. I really appreciated your description of the system and how it's supported by the dam safety program. Our dam safety program obviously is incredibly important, and we need the kind of objectivity and clarity that you provide. And our dam safety program helps us understand and make well-informed decisions around both managing risk and making investment of public dollars. People's lives and our regional economy really depend on solid risk-informed decisions, and we are really fortunate to have one of the best dam safety programs in the nation, and fortunate to have Ross here with us managing that program. I want to thank everyone who was able to join today for being here in this difficult set of circumstances. I hope that you and your families, the people that you care about, and your communities are doing well. And I appreciate the opportunity that this affords for me to share a little bit of perspective and some information about our conservation season upcoming and this really important subject of water management in the Willamette Valley. At the onset, I want to say thanks to the team because this doesn't happen without a team of people working together to pull something like this off. So I want to thank Dustin Bankston, Lauren Bennett, Selena Hart, Greg Taylor, Christy Johnson, and Alan Davis for facilitating this adaptive approach to reach out and share information with the public. And I hope and trust that what we're providing today will be both insightful and a productive use of your time. I'm going to talk a little bit about our current priorities and just very briefly touch on where we're at with respect to managing in the context of COVID-19. I'll also provide a snapshot for where we are right now with respect to water management towards the end of our refill season. I want to spotlight snow conditions and precipitation data that will help you to understand how we got to this point in time and what the status of our reservoirs and conservation season is. I'll do some comparison of this year's reservoir elevations to other recent water years. I'll also walk us through the forecasts for reservoir levels anticipated this season and talk a little bit about some trade-offs we've made to get to the storage place that we are. We'll also offer a chance to ask questions or make comments via the chat feature of this interface. It's worked well this week, and so I hope that people are able to use it today to get their questions elevated, visible, and responded to. So we have a staff of about 150 people in the Willamette Valley that operate and maintain the facilities that manage water and produce power and provide habitat for land and water living creatures. And so it's not one of those jobs that people can just walk away from and telework from home. Most of our staff on any given workday is showing up for work. And our priorities, as I laid out for them at the onset of some of the changes we've experienced in this country due to the pandemic, have been these right here. We continue to work, we continue to manage water flows and storage, maintain safe facilities, produce power, protect assets, protect natural and cultural resources, and to manage fish passage. We've adapted our approach. Our teams have sustained our work effort without much impact at all to our mission, while keeping people safe through scheduling separate shifts, through isolating control rooms, and working people at locations that are usually unmanned. Most of our support staff is teleworking. We're maximizing teleworking, and really people have adapted well to the challenges of the new environment. It is also noteworthy that many of our recreation areas have opened up this week, are opening back up in concert with the governor's initiative to gradually relax restrictions. And we expect to see a lot of people outside today and through this weekend as we begin to experience 80-degree days and beautiful weather. Nationally, we have really supported a couple of different FEMA missions, and as part of that, in Oregon, we've conducted facility assessments in Silverton, North Bend, and in Eugene. And a facility in Eugene is currently under construction now and will be used for treating and quarantining, I think, mostly unhoused persons and kind of load shedding from some of the fairgrounds facilities that are being used right now to support that population. So we're glad to be participating in some of the national emergency efforts right here in the city of Eugene. Let me move on to talk a little bit about our water year and current conditions. Of course, the diagram that you see on the left there is our Willamette Basin teacup diagram. This is available online, and it's quite interactive. There's an awful lot of data associated with it. It's available to the public. As you know, if you click on any of the orange squares there, you'll get information about particular reservoirs, elevations, inflows, outflows, lots of data that's just readily available to you. If you click on any of the green squares, those are control points that help us manage water and monitor what's happening downstream. And then you can also see by clicking on the blue dots what's coming into, what the flows are on tributaries coming into our reservoirs. So just a tremendous amount of data. There's a link at the end of this presentation that you can use to connect with this data if you've never been there and not familiar with it. Also, it comes up if you just Google Willamette teacup diagram. Current conditions, every water year is different, and the timing and distribution of precipitation in the basin really have a lot of bearing on where and how this system refills. So our current teacup diagram here shows that we're behind refill. We're behind about 21% of where we would ordinarily expect to be, and that puts us at about 78% full, or 22% below the top of our conservation storage. It is important to note that some of the activities that we had for managing water earlier in the year at lower levels during the winter months, like Detroit, we were doing some spillway gate work up there. We lowered the pool below the minimum at Detroit, but we were back to the water control diagram at the time that we began refilling the system February 1st. So the gate construction there didn't have bearing on refill. Interim risk reduction measures for dam safety that Ross mentioned at Hills Creek and Lookout Point, those restrictions that we have in place to manage seismic risk as we continue to better understand it through issue evaluation studies and dam safety modification studies, we're not going to come anywhere near approaching the elevations where we would be restricted, because the water year has been pretty lean. We're way behind. So if you look at Hills Creek and Lookout Point, we're 30% and 29% behind at those particular locations, and we're not going to get up to those restricted levels. Here's what happened. As we look back to precipitation across the Willamette Basin, we can see beginning in February that most of the precipitation that we had is well below average. In February, most of the precipitation was 50% below, or most of the basin was 50% below ordinary expected precipitation. In March, it was a little bit better. More of the extraordinary precip, and in May we rebounded a little bit where we had normal or above normal precipitation for the data that we have noted here the first 4 days in May. It is important to note that in May, we begin to dry up a little bit, and so even extraordinary precip above average in May, while it has bearing, it's not going to make up for 3 months of really, really dry weather. To do a little comparison between 2020 and 2015, you can see that each of the months, February, March, and April, really have been either comparable or drier in 2020 than they were in 2015. And 2015 was a pretty rough water year. We didn't have a lot to work with in 2015. The difference for us in 2020 is that we had better snow water equivalent. We had more snow, and while this is very much a rain-driven system, not a snow-driven system, it's a rain-driven system. The snow has helped us out this year. The graph on the left shows really up through the winter up to about the 4th of May. This black line is the snow water equivalent, or it's the water that is tied up in the snowpack across the Willamette Basin. Ordinarily, the peak snow water equivalent on average is back in late March, early April. Our peak snow water equivalent was a little bit later this year than what it ordinarily is, and it almost approached normal or average. And as a consequence of getting this kind of late peak snow water equivalent and then having it come off fairly quickly in April, that had a positive impact on being able to refill reservoirs. So at the beginning of April, the snow water equivalent in the system was about 110%, so just above average. Now, on May 5th, we were at about 59%, so well below average, which means all of that snow came off in the form of water and augmented flow into our reservoirs and helped with storage a little bit. And we see that bump up as we look at hydrographs ahead. So again, right now, snow water equivalent 59%. It's not going to have a lot of bearing on the rest of the spring season refill as we move forward. The climate outlook, the longer term outlook appears to be warmer through May with an equal chance of either above or below average for precipitation. Again, going to be hot and sort of average precipitation, we don't know. Where that puts us is really in severe to moderate drought across the basin. So to recap a little bit and then relate this to flow management, we collaborate with the Bonneville Power Administration, the National Marine Fisheries Service, U.S. Fish and Wildlife Service, Oregon Department of Fish and Wildlife, and other stakeholders to manage this system to meet the 2008 biological opinion we have for salmon and steelhead. And that biological opinion helps define some objectives for conservation season releases for water quality and for fisheries habitat. So this year was, as you saw through the maps and the precip conditions, it's been a difficult water year, difficult start. Conditions have been marginally improving with a little bit more rain coming a little bit later, and with that having some positive bearing on the snow water equivalent snow coming off. A lot of variability in the system. The South Sandy M is in pretty good shape. The North Sandy M is in better shape. The McKenzie subbasin is not rough, but south end of the valley, particularly the Middle Fork and the Long Tom, have been pretty heavily impacted by drought. In order to achieve as much storage as we could and balance some of the trade-offs between capturing that water and refilling some of these reservoirs for use of that water later in the year versus using that that water right now to sustain flows. We made some, working with partners, we made some trade-offs. And in the Willamette Valley this year, we had no main stem water quality targets in April, partly because the water coming in was cool. We had a little cooler spring, and that was helpful. And then we had some modified main stem targets in May. And as a consequence of that, instead of having about 900,000 to 1 million acre feet of storage in the system, we ended up we'll be able to achieve about 1.2 million acre feet of storage by May 15th. And that's really good. That's positive. That will allow us to use that water later in the summer as both tributaries and main stem Willamette River flows get warmer, and we can improve both habitat and water quality a little later in the season because we made those trade-offs early with our partners. We really have an adaptive process, and we meet multiple times a week, informally, and then once a week formally with all of our partners. Again, just to recap, we had no augmentation for April main stem Willamette flow targets. We had reduced biop minimum tributary targets, 1,100 CFS on the South Sandiam, 1,200 CFS on the North Sandiam. Both of those would ordinarily be about 1,500 CFS for April. And in May, we've adjusted May main stem flow targets based on conditions. So in May, we'll have a rolling average of 15,000 cubic feet per second over a 7-day average, and a minimum hard lower limit of 13,000 cubic feet per second. That's less than where we would ordinarily be. We'll continue to assess tributary targets and consult with our partners, and based on what we need to do given conditions to optimally adapt, we'll work to optimize the water that we have available this year. Again, a pretty good outcome, 1.2 million acre feet by the middle of May for what would ordinarily have been a really horrible storage year. Let's take a look at actual hydrographs of reservoir forebays. Starting up the middle fork, this darker red line is actual for 2020. And you can see that we're about where we were in 2015 at Hills Creek, although the rate of rise is steeper at this point in time for Hills Creek than it was in 2015. This just gives you some comparison to where we've been in other years. Lookout Point, similarly, we're above where we were in 2015, a little closer for Lookout to where we were in 2018, and the rate of rise is still a little steeper than where we were in 2018. Again, 2015, if you think back, that was a pretty horrible water year. I remember on New Year's Day that year hiking up on Willamette Pass, snowshoeing into the Maiden Peak snow shelter and spending the night there. And that was the last time that we went snowshoeing that season in 2015, because it seems like after that weekend, the snow came off and we didn't get any more snow really at mid elevations for the rest of that winter. So again, this winter we have the effect of snow, and it's helped out more dramatically than it would in an ordinary water year. Fall Creek, better than 2015, not quite what it was in 16, but still climbing there at Fall Creek. Fern Ridge, this is unusual. Fern Ridge, we typically don't have a difficult time refilling because it's a fairly shallow lake, not a lot of volume of water there. But this year we're having a difficult time refilling Fern Ridge. Conditions in the Long Tom watershed have been drier than the rest of the system, and our refill season has been worse than in 2015. We've been at minimum outflows, 50 cubic feet per second, since early February, which is really remarkable. I don't remember a time. I've been in the Willamette Valley since 2004, and I don't remember a time that we've been that dry at Fern Ridge. This week we made a decision to throttle back our releases from Fern Ridge Dam to just 30 cubic feet per second, and that's below our ordinary minimum flows. Again, we did that in partnership with the resource agencies, which is how we make decisions. We may get some additional rainfall this next week that could help out a little bit. I continue to watch the forecasts, and it looks like it may be a little damper, but we're going to need a lot more rain than a few days of showers in order to recover from where we are right now. So I'm not optimistic that we're going to refill at Fern Ridge, nor am I pessimistic that there won't be recreation opportunities there. There will be. We're close up to elevation, almost elevation 370. Most of the boat ramps are available. Some of the marinas may be impacted, or parts of the marinas may be impacted a little bit more than what you would ordinarily expect to see there. Cottage Grove, we're a little bit below 2015. You can see, get a sense of where recreation facilities are available there. Wilson Creek is the flat line elevation there. Dorena is one of our flashier reservoirs, and we're right up on the water control diagram there, or just off. So Dorena looks pretty good, and Dorena is typically a facility that refills pretty easily and frequently. Cougar, we've got a pretty good trajectory there for refill. Blue River, similarly, we're up near the water control diagram where we should ordinarily expect to be, and those are just reflect different conditions of the Mackenzie subbasin this year for precipitation. Green Peter looks to be fine for refill. That's going to help us use some of that stored water at Green Peter outside of Sweet Home to help augment main stem flow targets later in the year. Foster is a re-regulation facility for Green Peter, and typically it holds steady during the recreation season or during the conservation season, and it will this year as well. If we used storage from Foster to augment flows, we would only get a few days of water available to us to do that. There's not a lot of benefit there, and that water is beneficial for other purposes. So, Detroit, very popular recreation reservoir. We've seen improvement in our forecast over the last couple of 3 weeks, and it has benefited from some of the snow coming off of the hill, and so we're optimistic that we'll get closer to filling at Detroit. I'm going to go into some of the modeling for the rest of the season by reservoir, and so we'll talk a little bit about what we expect to see in more concrete terms. And as we look at Hill Creek, and as you look at this diagram, this dotted line represents where we are right now in time, beginning of May. And these trajectories, different colored lines coming out from this point, really represent the range of variability in the probability forecast ahead. The median, or 50% non-exceedance curve, is this blue line right here. And the red line means that there's a 95% chance that we won't exceed this red line. The plum-colored line at the bottom represents a 95% chance that we will exceed this line. So this is the lower limit of our modeling. This is the upper limit of our modeling, and this is the median of our modeling. So you can see Hills Creek. It doesn't look like a very good conservation season this year. Part of what we do in our modeling is we project where we're going to pull water from in order to meet main stem targets. So those assumptions have been built into the models and are reflected in the probability curves that you see ahead. So that's Hills Creek. Lookout Point, similarly, both Hills Creek and Lookout Point are two of the reservoirs that we use early on to augment flow because they're farthest up in the watershed. They're large storage reservoirs, and they benefit both the Middle Fork and the main stem Willamette for a some of the water from Fall Creek to augment downstream. Forecast for Fern Ridge, again, we'll approach 370 or so, and then begin to gradually taper off. Expect to see a reasonable utilization of water there for the conservation season and recreation opportunities there as well. Cottage Grove, going to rise and then begin to diminish there. Cottage Grove is a fairly small reservoir, and so it doesn't produce great benefits for the overall system and main stem Willamette water quality goals. Serena looks like a pretty good conservation season there. Anticipating getting very close to filling in June at Serena. Cougar, you can see refill probability is strong, but we'll use Cougar to augment flow for the South Fork and main stem Mackenzie's, and then also for water quality on the main stem Willamette fairly early, so it will be aggressively drawn down. Blue River, similarly, will peak somewhere fairly close to full, and then begin to pull that water for downstream use. And here's Detroit again, getting pretty close to full and holding fairly full. We release from Detroit for the main stem. We impact much less of that main stem reach than we do comparatively from Hills Creek and Lookout Point. Green Peter, South Bend EM, will reach full, and then beginning in June, really begin to utilize that water for augmenting targets downstream. And there's the forecast for Foster. So I ran through a lot of graphs really fast. It is important for you all to remember that every water year is unique, and that our forecasting has limitations, and that we can be thrown anomalous events like the atmospheric river that we had last April, which was fairly unprecedented for that water year precipitation coming at that time of the year. But you know, every year is different, and we can have situations that are anomalous that impact us in different ways. So recognize that. Our adaptive management this year has improved system storage projections. That's a really good thing, and I applaud our water managers, our biologists, and our partners for being able to come together and work out solutions that better optimize water resources and stored water for this season. Timely precipitation and some snow melt runoff is improving our forecast. Some basins obviously are going to be more impacted than others. The Long Tom and the Middle Fork are more heavily impacted by drought than other parts of the system. Our flow targets remain under constant assessment, and we'll continue to manage adaptively through the course of the season. And it's our intent as well to communicate as forecasts and flow conditions change, to communicate those changes with you and to help you, our stakeholders and partners, understand what the trade-offs are, why we're making them, and what the path forward ahead looks like. So that's my summary. I want to say again, thank you for taking time out of your busy schedules to join us today. That if you put a question into the chat box, you'll be assured that you'll get an answer, and that they'll be posted on our district website. Also, there are a couple of helpful links there. Our Portland District website, the Willamette Basin teacup diagram, and the Northwest River Forecast Center. Links are there. Also, we've got a general email inbox. The address is there, as well as a phone number for our public affairs office. And those folks will be really glad to help you any way they can, help you to understand what's going on and provide information to you. If you have questions, submit them in the chat box, and please let us know whether this was valuable to you, whether this forum was helpful, whether you gained understanding by us providing the data the way that we did. And again, thank you very much for your time and for
presentations, and thanks to everyone who listened in. This is going to be posted to our website hopefully soon. I'm going to be working on that later today and on Monday. If you have any questions, just enter them in the chat box and we'll get to them now and post those to our website as well. Thanks for joining.